work that I even presented to the World Congress on Genetics Applied to Electric Production last week. And so, as the previous presenter, Michela Blondi, said, the Holstein breed is the most spread dairy cattle in the world, and in Italy it's even linked to typical production. As an example, Parmigiano Reggiano, and for this reason, ANAFI even defined the cheese making and sustainability index Parmigiano Reggiano. And so with this in mind, we decided to do this analysis. I will present you, and the aims of our study are to assess if the Italian Holstein is distinct from the North American population, and if the different selection goals in the Italian population may have created some distinctiveness within our population. So, and then we did some signature of selection analysis to identify which are the genomic regions are involved in this differentiation of the Holstein in Italy. So, in order to do this, we retrieved our 280 genotypes from the ANAFI BJ database, and the first step was to define our populations. So for the North American Holstein, we selected 101 North American genotypes from animals with United States and Canadian IDs. For the Italian Holstein, we chose 74 animals that were Italian for at least 3 generations, so at least 3 generations born in Italy. So the chosen sample, his parents and at least 2 grandparents. And for the Parmigiano Reggiano Holstein, we chose animals in the Parmigiano Reggiano area, which are farmed, bred inside farms that confer the milk to the Parmigiano Reggiano Consortia. The genotypes are in the ANAFI database are from multiple sources and are imputed by the software PedInput to an 86K SNP dataset. And this dataset has undergone a data filtering through the software PLink for minimal allele frequency and marker mistingness, obtaining a 79K SNPs dataset. So with this dataset, we then proceeded to our analysis, which were the estimation of the genomic diversity indexes as the genomic inbreeding in terms of FROH, expected and observed heterozygosity, and effective population size. Then we proceeded to an MDS analysis and an admixture analysis to analyze the structure of the populations. We later made our signatures of selection analysis with 2 different approaches. One is the genome-wide FST analysis that we made using the Bayesian algorithm Bayescan, and the second approach was a window-based FST analysis. So Windows-based FST analysis. So before we made these 2 analyses, we proceeded to the analysis of the linkage disequilibrium decay, and with the result, of this analysis, we decided to design the windows for the Windows-based mode and to choose the annotated genes upstream and downstream the SNPs resulted in the genome-wide analysis. The outlier FSTs were chosen in the top between the top 0.05% values for both the methods and the windows, and we chose to inspect only the windows containing more than four SNP, so from 4 to more SNP inside one window. So the significant SNPs were then searched on the QTL database for bovine cattle and on the reference genome in order to find the genes involved in these differences in the selection signatures. So our results were quite interesting. In the diversity indexes, it resulted that the two Italian populations, so the Italian Holstein and the subpopulation bred for Parmigiano Reggiano, had both higher diversity indexes values and lower inbreeding values than the North American population. Then in the multidimensional scaling analysis, we can see on the dimension 1 how the North American population and the Italian population are clearly differentiated, and the Italian population and the Parmigiano Reggiano population can be seen differentiated on the dimension 2. The results have been confirmed even with the admixture analysis, which is based on the log likelihood, maximum log likelihood between the populations. So at the dimension K3, we can see 3 well-differentiated population. On the red, we can see the North American population. In the middle, with the main blue component, we can see the Italian population, and on the yellow we can see how the Holstein bred for Parmigiano Reggiano looks more differentiated, looks differentiated among the other two, even if its structure is not clearly defined as the other two. Then I will present you the results of the selection signatures. So we identified for the genome-wide approach 40 top SNPs for each comparison, which involved in each comparison 25, 27, 48 genes in 12, 9, and 8 chromosomes. And in the window-based analysis, we identified 12 significant windows for each comparison, and the chosen windows, so the windows containing at least 4 SNPs were 10 for the comparison between Italy and North America, containing 9 genes in 7 different chromosomes, 8 in the comparison between the Parmigiano Reggiano subpopulation and the North American. So 8 windows containing 8 genes in 5 different chromosomes, and in the comparison between the Parmigiano Reggiano subpopulation versus the Italian population, we identified 6 windows containing 15 genes in 4 different chromosomes. So The conclusion of our work is that the Italian population is well differentiated by the North American population, and within the Italian population, the population bred for Parmigiano Reggiano is well differentiated too, and our analysis for the genetic indexes show how the Italian populations have better genetic indexes than the North American one. Not better, but higher genetic diversity indexes than the North American one. So now in the results of our signature of selections, we found we identified 55 genes having a role in productive traits. 17 of them were related to milk production, and is interesting as this one, KCN-MA1, because it's always associated in with the caseins and with the coagulation of milk. In the Windows-based analysis, we highlighted 29 genes, and 15 of them have been previously detected to be associated with productive traits, and 9 of the genes found in the 2 different approaches resulted, for the 2 methods, common for the 2 main methods. So 9 genes were highlighted in both the methods, and most of them were linked to dairy traits. And the interesting thing is that most of them were found in the comparison between the 2 Italian subpopulations and the American population. This is not surprising because the Parmigiano Reggiano subpopulation is a subpopulation of the Italian Holstein. And to confirm our results, we are really now doing repeating the analysis of the selection signatures, but using an haplotypical approach. So I've been quite fast. I thank ANAFI for the opportunity they gave me to work with them, and thank you for your kind attention. Rafael, I cannot say that.
No, I had forgotten. Is there any question?
Do you think the divergence?
Can you come here to me?
I cannot hear.
Yeah, 1 second. She's coming here.
Yeah.
Do you think like the divergence in the Italian breeds is more due to like the beta casein coagulation property, like the casein coagulation properties being like a predominantly cheese producing country?
So can you repeat the question, please? Maybe.
I think your accent's less thick than mine.
Do you think that the divergence is due to the beta casein in the Italian Holstein?
No. So the first time we made this analysis, we found a really big signal on the 6th chromosome, and then we realized that all of our animals we chose for the Parmigiano Reggiano, we chose animals that eventually were homozygote for the beta casein. So we resampled them, and and we remade our analysis, and the results on the population structure were really the same. So both selecting homozygotes for beta-casein, both discarding them, we obtain the same results. So I don't think it's only because of this. There is something more.
Okay, thanks. I don't know if there is any other questions. Yes. Yes, please come here, Christian. Christian to Christian. The double Christian.
Hi, thank you for the nice presentation. And perhaps this is a segue, a follow-up. I'm just wondering, what do you think is the driver of the differentiation of the Parmigiano-Reggiano cheese? Because I do assume that the selection objective is the same for the breed, right? So if there is like a conscious decision by the breeder, or if there's some exogenous.
Yes, my hypothesis is that the farmers, you know, in the Italian system, they have the opportunity to choose bulls or semen, you know, genetics for really different breeding values and genetic indexes, and there are animals, you know, there are farmers more interested in milk yield, and others like the one that breed for Parmigiano-Reggiano are more interested maybe in the proteins and fats. So maybe I think that is driven by the choice of the farmers, you know, by the genetics the farmers choose in the for their breeding, you know, for what they choose, for the genetics they choose.
Thank you. So just super quickly, did you find a difference in protein levels, breeding value for the two?
I didn't check this. This is an hypothesis. I hypothesize that these differences are made by these choices of the farmers, because for both the Italian and the Parmigiano-Reggiano subpopulations, we selected animals that had at least 3 generations born in Italy, and you know, everything was the same. The only difference between the two choices was the fact that the farms were conferring to the Parmigiano-Reggiano consortia. So this is all I can say. I didn't check the genetic indexes for these things, but my hypothesis is they do different choices because of the product they want to sell.
Christian, you have another question.
Okay.
Christian, the question is not for you, but I don't see the person that I was looking for, that is Maurizio, is not here. Oh, because I was following I was following the discussion between Christian Malteca and you, and I was thinking that maybe, since we are in the HOLSTEIN Association, maybe they know if the farmers in the Parmesan area are using significantly different bulls from farmers in other areas. They should know the answer probably, or so yeah. So I think they should do, but I really don't know if they do. So and this is something we were talking during the lunchtime. The discussion at the genetic level and the discussion at the farm level, sometimes they are totally different. They are like two different environments. So that's my small contribution.
Yeah, I just want to tell that when we chose the samples, we just chose with this criteria to not have, you know, other things in mind, and maybe have a, you know, some influence on what we see on the papers. So we just chose Parmigiano-Reggiano area, conferring to Parmigiano-Reggiano, and Italian. That means for us, for this sampling, 3 generations born in Italy.
We have here Maurizio, and maybe you can answer to this question. Maurizio, can you come here to the microphone?
I don't understand the question.
The question.
Is the question?
That is the question.
Okay. And Claudio asked me if the breeders of Parmigiano-Reggiano area choose bulls with another criteria respect to other Italian breeder. We have made a research in our database, and the only difference from Italian breeders of Parmigiano-Reggiano area and other breeders is the frequency of allele B of kappa casein, which is more frequent in breeders of Parmigiano-Reggiano area. For other criteria, for example, milk, fat, protein, other composite, feet and legs, longevity, fertility, the criteria is the same, because the XPR, I don't understand the correct, XPR is the new index for breeders that making a Parmigiano-Reggiano is made from a few years, and is a to reason to see a choice different from Parmigiano-Reggiano area and other Italian breeder. Sorry for my English.
It's fine. Is there any other question from the audience? No. Okay. So